We have two separate problems here. Let's look at the first one over here. It says you randomly select two cards in succession. Succession meaning you draw one card and then you draw another card. We're drawing from a standard 52 card deck without replacement. Without replacement means when I pick the first card, I keep it and then I pick a second card. Find the probability that you end up with two kings. When events happen in succession, we can use the multiplication rule for probability. We're going to find the probability of the first event, multiply it by the probability of the second event, and if there's more events, you just keep on multiplying. We only have two events here. The probability of the first card being a king, and then the probability of the second card being a king. All right, so I'm going to write this as the probability I get a king and then another king. All right, so I want to figure out the probability that the first card is a king. And then I'm going to multiply by the probability that the second card is a king. Given that the first card is a king, I'm going to use this vertical bar to represent given. So this is the probability that the first card is a king. There's 4 kings in the deck out of 52. So the probability is 4 divided by 52. That's the probability that the first card is a king. Now we want the probability that the second card is a king. Now it says without replacement, that means I keep the first card and then I select the second card. Now since I kept the first card, I no longer have 52 cards in the deck. I have 51 total cards. And I no longer have 4 kings because I kept the first king. So now there's only 3 kings in the deck. So the probability that the second card is a king is going to be 3 divided by 51. Because now there's 3 kings in the deck out of a total 51 cards. And if you work this out, plug it in a calculator or reduce it, you'll get 1 over 221. So the probability of getting 2 cards in a row, and they're both kings, without replacement, is going to be 1 divided by 221. Now let's look at the second problem. It's the same deal. Everything's exactly the same, except it says with replacement. You randomly select 2 cards in succession from a standard 52 card deck with replacement. That means I take the first card, I look at it, and then I put it back with replacement. Find the probability again that they are both kings. So it's going to be the same deal, same formula. The probability that the first one is a king is, again, 4 out of 52. And then I multiply by the probability that the second card is a king. Now, since I put the first king back in the deck, the probability that the second card is a king is the same as the probability of the first card being a king. There's 4 kings back in the deck, and there's a total of 52 cards back in the deck. And if you work this out and simplify it, you'll get 1 over 169. So you can see that the probability is higher of getting both kings if you do with replacement. So the first one was an example of a dependent scenario. The probability of the second card being drawn depends on what the first card was. They're dependent events. With replacement, this is an example of independent events. The second probability did not depend on the first event. There you go.